Westless Salmon lecture, which will be given by Jenan Ismail at 3:30 on the 10th floor. Is that correct, Mike? 3:30 on the 10th floor. And I guess it will be followed by a reception.
Yeah, very nice reception.
It will be a very nice reception. Beats everything we've ever been able to offer. So there will be alcohol. Next week, there is no in-person lunchtime talk. However, on Tuesday, we have an online talk. It's part of the featured former fellow lectures, which will be given by Agnieszka Bolinska, who was here a few years ago, and we will be talking about understanding integration, lessons from integrative modeling in structural biology. So the talk is online, and you can find the Zoom link to attend the talk on the center's website as usual. On Friday next week, there is no lunchtime talk, but we have the ALS lecture at 3:30 on the 10th floor again by Kaylin O'Connor from LTS Irvine, who will be talking about why natural social contracts are not fair. And the first workshop / conference organized at the center is coming. Mike here will be organizing a conference on rethinking anomalies in science on Friday, October 27 and Saturday, October 28. Registration is required. So if you want to come to this lecture, you must register, and the link is available on the website. So if you're interested in that question, please go on and register. We need a head count to make sure we don't get thousands of people in this moment. Today it's my great pleasure to introduce David Klinowski, who is a visiting assistant professor of marketing and business economics in the Graduate School of Business here at Pitt. Before that, he was a postdoctoral fellow in the Department of Economics at Stanford. And before that, he got his PhD at Pitt. So it's actually a return home in some way. He's published extensively on topics that will be related to today's talks on the place of women in science, in journals in economics, such as a Review of Economics and Statistics, Experimental Economics, but also in PNAS a few years, 3 years ago. David, thanks for coming, actually. David reached out to me, and I'm really delighted we were able to organize these talks. So the title of the talk is Voicing Disagreement in Science, Missing Women. Thank you very, very much.
Thank you, Bill. Well, thanks so much for having me here. It's a great pleasure to be with you. This is an unusual opportunity for me to get to talk with non-economists, so I'm quite happy to be here. Yeah, so maybe just a few words about myself. So as Edward said, I'm an economist at the business school. I use observational data and also experiments to study two kinds of topics. One of them is the gender gaps in education and labor market. And the second one is the economics of science. And today I will present a project that combines both methodologies and also both kinds of topics. So in particular, I will study who writes post-publication criticisms in the scientific literature with a focus on gender differences. Yeah, I think. That's just like
Here we go.
Okay, so right, so well, as you are much more aware than I am, philosophers of science and sociologists of science have written a lot about how science makes progress, both when scientists generate new ideas, what has been called conjectures or discovery, but also when scientists debate and criticize ideas, what has been called reputations or resistance by scientists to scientific discovery. Yet we rarely, if ever, make this decomposition of science into these two components when we study gender differences in participation in academic science. We know women are missing in science in general, for example, as authors in the scientific literature or in the faculty of most fields. But the question I ask in this project is, are women missing even more in the criticism component of science? And I argue that studying this question can help us to better understand when and why women might be missing academia. So the way I study this question is by by studying two standard ways by which scientists communicate post-publication criticisms in the scientific literature. One is by writing comments that correct or criticize a published paper. And the second one is by writing replications that fail to find what has been found in a previous paper, so failed replications. And so in a second, I'll give you examples and details of these types of papers. But what I do is I use first bibliometric data to document gender gaps in participation or in authorship of these kinds of papers. Then I use the bibliometric data to try to examine some potential explanations for the gender gaps that we will see. And then I use an experiment to test more cleanly one potential mechanism, which is related to behavioral gender difference. All right. So my plan for today is to first talk about the comments. So I'll show you the data and the results. Then the failed replications, we'll go to the data and the results, and then I'll talk about the experiment, where I'll talk about the design and the results. And okay, so comments, as I said, so they are short papers that are intended specifically to criticize or correct a published paper. So they are typically peer-reviewed and submitted for publication to the same journal as that of the article being criticized. They are, in my discipline in economics, they're relatively rare. For example, in the American Economic Review, the flagship journal of the American Economic Association, I see on average one comment for every 17.5 regular research papers. But comments are more common in other fields. So for example, in medicine, in JAMA, the Journal of the American Medical Association, I see on average a comment for every 1.1 research papers. So it varies a lot by field. And also comments can be important, both for the literature and for the commenter. So for example, in the journal Nature, I see that the likelihood that a paper is retracted grows by 9 times after receiving a comment. And while certainly comments are not as cited as regular papers, they can be well cited. For example, again, in the American Economic Review, I see that of the 25% of comments in that journal receive more citations than 25% of papers, regular papers in that same journal. So even by the high standards of the American Economic Review, we see that sometimes comments do get cited. But comments can also take a confrontational tone, and even journals themselves sometimes have contributed to framing comments in a confrontational tone. So for example, here's an excerpt from what was at the time the official description of the comment section in the journal Nature, which, as we know, is one of the most widely read and prestigious scientific journals. And it says, a reader may submit an attack on the core of a paper. It is in our duty to take it up with the authors and referees. If the attack turns out to be well-founded, a retraction or correction will follow. And I can find plenty of quotes and descriptions by authors talking about how nasty comments and replies can get. Here is an example of a comment chosen for no particular reason in the American Economic Review, or the abstract of a comment. And it says more or less, the previous paper estimated some effects. However, we find that these effects are inflated. We propose an alternative estimation strategy. So you can see it's disagreeing and trying to correct. Here is a comment, again, chosen for no particular reason from JAMA, or the start of a comment. It says, a previous paper found that an intubation strategy was associated with greater survival. We have some concerns regarding the results and the applicability of the conclusions. So all these comments that I'm going to examine are of this critical type, are disagreeing with a published paper. And so, what I do is I collect data so I collect all the comments of this critical type and all the research papers on these 6 journals, the American Economic Review, the American Sociological Review, which is the flagship journal of the American Sociological Association, and JAMA, and the three foremost multidisciplinary journals, Nature, PNAS, and Science. And so for each journal, I collect all these publications that happen. Well, so the data always end at the end of 2019, and the start point depends on whether when the journal started publishing comments, on when it started organizing comments in a way that I can identify them clearly. So I want to make sure that I'm confident with what I'm studying at is actually these comments on this critical type. And so in general, I have data from 8 to 22 years journal. And so the way I construct the data, I basically go through the table of contents, online table of contents of each of the journal, and I scrape the data, and then I can observe all kinds of information. I collect the author's name, that's key for me. The title, the date, the issue, the field, whenever a field is observed. Then I use the author names to infer the gender. And so to do that, I use several strategies. The main one is I use this commercial service called genderize.io, which has a proprietary database that matches first names to gender. I also, as an alternative strategy, I use US Social Security Administration birth records, which also have names and matches to gender. And for the American Economic Review, I actually went through all the names and I searched for the authors and I assigned binarily gender. And so and by doing that, I can also corroborate the accuracy of the genderize.io and the Social Security Administration records in my data. Okay, and so I explained this, but I also I can construct a proxy of seniority because I might observe an author multiple times in a journal, and so each time I observe the author, I can count how many times I've seen them previously, so I can have a sense of their cumulative history of publications. And I also, in analysis, I don't think I showed today, I match data also with citations. So I told you a little bit about citations, so I have citations. Okay, so that was for the data, the construction of the data. So let me just show you some results now. So as you can imagine, what I'm going to show you here, or one of the main results I'll show is for each of these 6 journals across time, what is the share of female authors, first for regular papers and then for comments. So the share of the share of female authors in regular papers is designed right here. It hovers around 25 to 35%, except for economics, the one top to the left, which is 10 to 15%. So economics has a, I was just learning the philosophy as well, as a particularly bad problem with gender in our profession. All right, so and so notice also that this axis ends at 50%. So we are nowhere near parity to begin with. And also notice that this is already a highly selected sample of women. So these are women who are publishing in very competitive elite journals. And so now let's see in this already selected sample and this already depressed level of female participation, what is the share of authors of comments? And so that's this lighter line. And you can see for most journals and most time points that the proportion of the share of female authors, it's lower. In fact, it's statistically significantly so. So this is what this table is showing, basically the same information, just to indicate that relative to so in the bottom line, so this is the share, the mean share of female authors in regular papers. So compared to these rows, the drop of female participation in comments, it's in the order of 20 to 40%, and it's statistically significant, except for sociology, which I think is because of smaller sample. And so it's quite a substantial drop. And the fact that I observed for all the journals that I've examined suggests that this is not a field-specific or a journal-specific result. This is something that potentially there's explanations that apply broadly in academia that are playing a role. And so in the data, I can examine some potential such explanations. And so one of them, well, so I'll go through 3 of them. So one of them is just differential sorting into fields between men and women. Second one is maybe differences in seniority. I'll explain this, or co-authorship patterns. And so let's go through one by one. And so sorting into fields, well, it could just be, so just take any journal. It could just be within the journal, women happen to concentrate more in fields that just happen to receive fewer comments. So that's true, that just mechanically would produce the results that I've showed you. But that's actually not what's going on. So in 3 of the 6 journals I study, I can actually identify the field within the journal directly from the journal, because they make it obvious they stated in their publication. And so I can redo this analysis that I've shown you now within field. So I can control the field, and that doesn't change the results. So here's now in the same sample where I can observe the field. You compare this drop. So this is the comment. These numbers are the drop in female representation for comments. Compare that when you control for field, and most of the gap, if not all the gap, continues to exist there. And so it suggests that field sorting into fields doesn't really explain this. Okay. So how about seniority? It may be, and that was my prior when I started looking at this data. It may be that to be willing and able to criticize someone, you have to be senior enough. And we know in academia, that's very well documented, that women drop out quicker than men. And so in general, men are more senior than women in academia. And so if it is true that you have to be senior enough to comment, then just differences in seniority might produce this result. And so again, this actually is not what's going on. So let me show some data on this. So to have a proxy of seniority, as I said, I construct a history of publication of each author in the journal. So for some of the journals, I can actually observe way back before the journal even started having comments, but they have publications, and so I can even track them. For economics, the American Economic Association has many journals, all with the same sort of format of the data, so I can actually look more journals to get the history of publication of authors. And so then I can count, so every time I see an author, I can count how many times I've seen them before. And so now I can control for that in the analysis. I can say, well, so now conditional on how many times I've seen you before, is it true that men continue to comment more than women? And so that's analysis. Well, so before, I just also do some sort of sanity check to make sure that this cumulative history publications actually is capturing seniority. So one way you can test for that is, well, so in some of these journals, the convention is to have, for any paper, the senior author last. And so that's true in JAMA, Nature, PNAS, and Science, and most of these disciplines published in these fields. Whereas in economics and sociology, that's not true. The convention in economics and sociology is to list authors alphabetically, basically randomly. And so there's no reason to expect the last authors to be more senior. And so that's in fact what we find. So for the journals where the convention is to list the author last, if you look at, is it true indeed that for any paper, the last author is more senior based on my proxy? That's true. That's what these results are showing. Whereas it's not true as we would expect not to find it to be true for. So it indicates that that this proxy is indeed capturing seniority. Now it's also capturing, if I regress, or again, so how many times I've seen you before, anytime I see you, on whether you are a female, it is true also that women are less senior than men. And so this is also what we would expect. But now, if you look at who's commenting, it turns out that it is junior authors who are commenting more. So across journals, it turns out that it's not seniors, senior authors who are coming more often. Actually, it is junior authors. And so this makes it even more striking that women are missing in comments, because if anything, women are more represented in academia among junior scholars, yet we see them less often, right? So if we control for seniority, it actually widens the gap even further. Right? So if you compare now the results that shown you on top, which control for seniority, versus the one that I've shown you previously, the gap is actually large, right? So more than 40%. Okay, so then seniority also doesn't seem to be explaining why women are not commenting. How about co-authorship? Maybe one has to have co-authors to comment, or maybe one has to have the right co-authors to comment. And so if women for some reason don't have the same co-authors as men, maybe that could explain the results. That's also not true. And so in order to show you that, so let's do this exercise. So let's take now the paper as the observation. So the unit of observation is a paper. And let's see all the papers in a journal. So this is the American Economic Review first. So all the papers in the American Economic Review, take those papers that have at least one male author. And now ask how many of those papers with at least one male author are solo author. This would be by a man, obviously, and that's 19%. Right. So loosely speaking, you can think of 19% as the propensity of men to solo author regular papers. So let's ask the same for women. So all papers in the American Economic Review that have at least one female author, how many of those papers are solo author? And that's 16%. Right? And so now let's do the same for comments. So of all comments that have at least one male author, how many of those comments are solo author? And that's 33%. So again, loosely speaking, the propensity of men to solo author grows for comments relative to regular papers. How about for women, of all comments that have at least one female author, how many of those comments are solo author? There's none. So there's in my data, in the period of analysis, there's not a single female solo author comment. And in fact, this is a pattern that we observe across journals. Right? So for the American Sociological Review, the propensity of men to solo author grows for comments. For women, it drops. For, I guess this is JAMA, the propensity, while it is the case now that the propensity for women to solo author grows relative to regular papers, it doesn't grow nearly as much as it does for men. And this is true also for, I think this is Nature, PNAS, and Science. And so it's quite a pattern where women are also not willing to, at least to the same extent as men, comment solo. Whereas men are. And so the point here is also that you don't need co-authors to comment. Like men are, the propensity to comment is actually to comment solo author is substantially larger than for regular papers. So it indicates that you don't really need authors to write a comment. And so women, they are not participating. And what? So this regression is just to show that these differences in differences that I've shown you are statistically significant. This is quite a strong result. So I've gone through 3 explanations. There are many other potential explanations that you might think and that are consistent with the results that I've shown so far. One, for example, it may be that women criticize as much as men, but maybe they're getting rejected in peer review more often than men. So that's why we don't see them in the comments. Or maybe it may be that well, so first, we know that comments are not as valued in our profession as regular research, as original work, right? And so we are all career-minded. Which is the case, if women face greater barriers to progressing in science, maybe it makes more sense for them to focus on original papers than commenting. And so there are many other explanations. I'll go to some of them later, but so let me now show you data from failed replications. And one nice thing about this data is that I think they can speak a bit to these 2 explanations that I just mentioned. The potential greater rejection rate for women, and the fact that they might be prioritizing novelty more than men. Okay, so in this part of the paper, I use data from bioRxiv, which is the leading repository of preprints, working papers in the life sciences. It covers a wide range of life sciences. It's quite popular in these fields. And so the data, I use all papers published in bioRxiv since it started sometime in 2013 until the end of 2019. So again, I web scrape all the data, all the papers have been posted here. And I can also collect information such as names and titles and so on. One nice thing about the bioRxiv for me is that once papers are posted on the platform, they cannot be deleted. They have to be there. They can be edited, but cannot be removed. And so I'm sort of confident that I'm collecting lots of papers. And another nice thing for me is that when authors post a paper on the platform, they have to indicate whether the paper is one that reports new results or confirmatory results or contradictory results. They have to choose one of these three when they post a paper. And as stated in bioRxiv, new results describe an advance in the field. Confirmatory results are replication that largely confirms what's been found previously. And a contradictory result is just a replication that fails to find the previous result. And as you can imagine, most papers are new results, but there are enough replications and successful and failed replications for me to compare the share of female authors across the three types of papers. And so that's what I will do. I will examine what's the share of female authors in each list. Right. Okay, so let me show you that. So again, this will be across time, the existence of bioRxiv. What is the share of female authors? First, for new papers, new results, that's hovering between 25 and 35%. For confirmatory or successful replications, that's a similar trend. For failed replications, there's a drop of 16 to 19%. I can also look at, well, so this is a regression just showing the same information, but now with statistical tests. So this is a significant drop for failed replications. And in fact, it survives if I do the analysis within field. So I've shown you many fields in bioRxiv. You can replicate the analysis within field. The results are still the same. All right. So another thing we can look at is that first authors. So in many of the life sciences, the convention again is to list first the author who made the biggest contribution or who pushed the project most forward. And so it may make sense to look at first authors. And so that's what I'm doing. And so I'll just repeat the analysis, but just looking for each paper, just the first author. And again, so if you do that, the share of female authors of regular or new results, that's again between 25 and 35% more or less. A similar trend for confirmatory or successful replications, and for failed replications, actually now the drop is even larger, of about 40%. And again, it's statistically significant. And so finally, I also look at solo author papers in bioRxiv. So among all the solo author papers, how many of those are by women? That's 10% for new results, 14% successful replications, 6%. So it seems to be a pattern where no matter how you examine it, women are missing in failed replications. And well, this time these are not statistically significant differences that I've just shown you, largely because there's so few failed and successful replications. Right. So these are the results that I've shown. And again, I think these results are interesting in part because they suggest that women can be missing in criticisms even before peer review. So these are working papers. And not only that, the fact that we observe women in successful replications, but not in failed replications, suggests that the reason why we don't see them in failed replications is not that they're prioritizing novelty, because we are seeing them reporting replications. So it's just not successful. And so it doesn't seem to be that they are writing. The reason is that they're writing, just focusing on writing original results. Right. So now let me go to the experiment that I've conducted here. And so there are also plenty of explanations that probably playing a role in these results, besides the ones that I've examined so far. One of them could be calling behavioral gender differences. So that's the term we use in economics. Basically, differences between men and women in preferences or traits or beliefs that relate to criticizing someone's work. So if there are differences in that, maybe those could play a role here. Women may also be anticipating discrimination in the field or anticipating backlash in the profession. Like if they criticize someone, maybe they will receive backlash by their colleagues. But they could be anticipating this accurately or inaccurately. But this is true. Maybe that's the reason why they're not participating in criticisms. And so in the experiment, I examined one potential explanation within the behavioral gender differences category, which is differences between men and women in preferences for pointing out a mistake in someone's work and taking away credit earned from that mistake. And I just want to be very clear here. This is not to say that I'm ruling out these other explanations. Quite the opposite. I'm going to construct an environment that abstracts away from these other compounds or explanations precisely because they might be playing a role. And so then I can ask, in this cleaner environment where I've stripped away other explanations, is it still the case that we're observing differences between men and women in behavior? So that's the idea of the experiment. Okay, so the experiment, so I conducted this experiment online. There's on the platform Prolific, which nowadays is a very standard platform for running experiments in economics and the social sciences. And so in this experiment, I match subjects into pairs. You can think of one of them as the author and another one as the commenter. So the author has to solve a task. So this task, I show them a matrix of zeros and ones, and in 2 minutes, they have to count how many ones there are. And so if they do this correctly, they receive $1. But there is a false positive rate in this task, meaning if they don't solve the task correctly, then with 50% chance they earn 0, but with 50% chance they receive the $1, or the earnings say that they receive $1, even though they solve the task incorrectly. Right? And they are not informed of whether they solve the task correctly or incorrectly. They're only informed of the earnings. And so this is a sense in which this is a false positive, analogous to introducing a false positive in the literature. And so again, so the author is informed of the earnings at the end of the task, but not whether they solve the task correctly. And also they're informed that at the end of the experiment, the actual payment of the earnings depends on the decision made by the other subject they're matched to. That other subject, which I'm calling here the commenter, I didn't use this language in the experiment. I use very neutral language. But so these other, the commenter, they also solve the task, this time without a false positive. But before solving the task, they have to choose whether to contest the false positive of the author. And again, I didn't use the word contest, but just for explanation here, contesting means to inform the author that they made a mistake and take away the $1. And I implemented this as a contingent decision, meaning that if the commenter chooses to contest, this is implemented only if indeed there is a false positive, and if the commenter herself or himself solve the task correctly. And the way the reason I do this is that I want to minimize the potential role of the commenter's beliefs in the decision to contest. Like, so you may imagine that if you're going to criticize someone, your decision to criticize may depend on whether you think a person made a mistake or whether you think you would make the same mistake. And so if there are differences in beliefs, those might affect why or when people decide to contest. I want to rule out or control as much as possible explanation. So the commenter doesn't have to guess this. So I implemented only these are two orders. So it's a contingent decision. Okay, so in terms of monetary consequences of what I've just explained is the sign, the decision to contest is really just a decision between two sort of payoff matrices, right? So in one case, you take away $1. In another case, you don't take away $1. And so under some contingency, you take away $1. And so it could be, so if we observe differences in the willingness to choose to contest between men and women in this experiment, it may be that there are differences in what we call distributional preferences. Preferences of distributing money between myself and some other person. Right? Nothing to do with a task or taking away credit earned for a mistake. Right? And so I also want to be able to control for this or examine whether these distributional preferences are playing a role in the experiment. So I conducted also another treatment arm administered with to a separate set of subjects in the same experiment, so across subjects, in which the subject P1 has to choose either matrix 1 or matrix 2. And in that matrix that determines a distribution of money between P1 and some other person. There is no task here, there is no false positive, but the stakes are designed such that they are as close as possible to the monetary stakes of the main experiment, and also the probabilities of these contingencies. Right? And so if I observe gender differences in these choices over matrices, then I can at least use it as a benchmark against which I compare the main results to see, well, how much of distribution preferences are playing a role in the main decision to compare. Okay, so let me just show you the main result of this experiment. So let's look at the share of subjects who choose to contest this experiment or choose a matrix, the equivalent matrix in the money-only treatment. And so then first for men, about 40% of subjects choose to contest. Women, that's 16%. These are 95% error bars. For the money-only treatment, the equivalent matrix is chosen 16% of the time by men and 5% of the time. So one interpretation of these results is that women in this experiment, female subjects in this experiment, are 60% less likely to contest the false positive than men. Half of this gap might be explained by distribution preferences, differences in distribution preferences between men and women, but half of the gap remains unexplained after you control for this. I would suggest that maybe men are also motivated by some other things besides distributing money, such as maybe telling the other person that he was wrong or she was wrong and take away credit earned from a mistake. So that's one interpretation. Yes.
Just make sure I understand. Do participants earn the dollar that they take from the other person, or do
well, yeah. So I actually run 3 different treatments, modifying exactly what happens to the dollar. In one treatment, that dollar is destroyed. So you take the dollar away from me if I made a mistake, and that I don't get the dollar. So this experiment also has there's a fee for participating on top of the dollar that you may earn on the task, right? And also I elicit beliefs, so there's a chance that they may earn more than just $1 on the task. And so, but if at the end of the day I actually made a mistake and you decided that you take away that, then that dollar gets destroyed in one treatment. In another treatment, if you decide to contest and it's implemented, we split the dollar. So you keep half of that dollar, you take it from me, and I keep half. And in another treatment, you take the whole dollar. So so I'm not showing you these results, but actually the results are the same, or not the same, but so the option for you to take the dollar away from me rather than destroy encourages you to contest more. So that is true for both men and women. So and it's what we expect. Right? So there's a stronger monetary incentive to contest. So we see that it results in more contesting, but the gaps continue to be true. Thanks. Okay, so it might be my computer. It's my computer. All right, and so this is just a regression of the results. So the likelihood that a female in this experiment contest is 60% less than for men. And then once you control for these distribution preferences, there continues to be a significant residual gap, which is what I was explaining. Okay, so I don't know if I went too fast or no, but that this is.
No, you actually have it's good, about 10 minutes if you want.
Okay, yeah. So I just spent a couple of minutes concluding. And so just to remind you what I've done. So in this experiment, I asked, are women missing even more in the criticism component of science? They are missing by 20 to 40% in post-publication comments across scientific fields. And this is not explained by differences between men and women in sorting into fields or in seniority or co-authorship capacity. In failed replications, prior to peer review in working papers, we see also that women are missing by 60 to 40%. And we don't see them missing in successful replications, which suggests that this is not explained by women pursuing novelty more than men. And in this experiment, I find that women are 50 to 60% less likely than men to choose to tell the other person that they made a mistake and penalize that mistake. Okay, in terms of implications, I think these results raise questions for us to think about, those who participate in science, who study science, who might be able to design incentives for institutions in science. First, so how much is the process of knowledge accumulation and self-correction in science delayed by the lack of female participation in this part of the literature? If we think of academia as a labor market, are women affected? Are women's outcomes affected when they criticize? Or are they affected when they do not criticize by the lack of participation? Are the outcomes in academia, labor market outcomes affected? It also raises questions about what, whether these proposals, obviously there's this replication crisis, and there is proposals to encourage or incentivize replications. Are they going to attract men and women equally? And so one of the, at least in economics, one proposal is to have in a journal a replication section, just like we now have, as I've shown you, a comment section where women are missing. So maybe women will be missing also in such a section. And more generally, how can we redesign the incentives and institutions in science to encourage participation of men and women in this important part of science? Thanks so much.
Break as we always do, in case some of you need to leave, and then we'll reconvene in 2 minutes for the Q&A.